Anytime we talk about variance of a population, we use a bell curve to represent the distribution of those traits in that population. And so, for example, if we looked at rabbits, we might say that this is a normal distribution, similar to humans. There is a medium-sized rabbit, which is like me, or maybe I'm over here. And then you have Sean O'Shea, our principal. He is over here. He is very tall. And then you have very short people over here. It's the same thing with rabbits and every other organism. They all have a bell curve. A bell curve is really just a combination of bar graphs, and so we could write it like this instead. This many rabbits will be this size. This many rabbits will be this size, and this many will be this size. There will be some that are very small, and a very few that are very large. And all that is a bell curve. This is because it is a polygenic trait, which we talked about in genetics. How does that curve change due to selective pressure? For the the hawk, and the grass, this meant that the smallest rabbit had the greatest advantage. And so, if the bell starts like this, how will it change? In this example, it will go in this direction. This is called directional selection. The population over time will become like the red curve because the large rabbits die and the medium rabbits struggle. The small rabbits thrive, and so the population has moved in a direction. Let's get a new selective pressure and see what happens. Here we have a snake, and the snake can only eat small rabbits because his jaw is not big enough for the larger rabbits. It can eat some of the medium rabbits, but very few. We still have the hawk and the tall grass. And so, what does this mean? We start with our normal curve, and then we see that the large rabbits are eaten by the hawk, and the small rabbits are eaten by the snake. This means that the new curve will be pushed in. We call this stabilizing selection because it reinforces the average. The stabilizing selection will reinforce the average, which is the medium. This type of selective pressure tends to prevent a species from speciating, which means to become a new species. And that is why it is called stabilizing. The last type of selection is called disruptive. Here we have a tall plant that is so tall that only the largest rabbits can reach the fruit at the top. Only the smallest rabbits can crawl underneath and get the fruit down below. The medium rabbits have a hard time doing either, and so they starve. And so in this example, we started with a normal curve, but we ended like this. And so the curve moved apart. This is called disruptive selection. Generally, this will lead to speciation. We may end up with a large rabbit species and a small rabbit species with different niches.